We wait any longer or?
Understand? All right. Hi, everyone. Welcome to this session on LLMs. So, if you didn't attend the MLOps session, I am
We
Abhineet
wait any
Gupta.
longer or?
a-
Just a sec, just a
And
sec.
all right. Hi, everyone. Welcome to this session on LLMs. So, if you didn't attend the MLOps
I
session,
think
I
I'll start
am
with the
Abhineet
intro. Wait any
Gupta.
longer or?
a-
Hello. Just a sec, just a sec.
Yes, I can still
Okay.
hear you. Okay.
Right. So, hello everyone. I'm Sanchit. I'm an associate at the Consulting and Analytics Club at IIT Guwahati, and I would like to welcome all of you to this live session in the Summer Analytics course. It's my pleasure to introduce our keynote speaker for today's session, Mr. Abhineet Gupta. Mr. Gupta is an applied machine learning scientist at Shopify with over a decade of experience in data science, risk forecasting, and building scalable ML systems. This is our second talk session with Mr. Gupta after the successful chat on MLOps. Mr. Gupta holds a BTech degree from IIT Kharagpur, followed by a master's and PhD from Stanford University. He has spent more than 8 years developing reliable machine learning models across diverse domains. He spent years in bridging academic research with real world industry applications. Today, he'll share his expertise on large language models and, importantly, how to effectively read and interpret research papers. This is a skill that's crucial for anyone who's looking to take the next step after this course, whether it's in advanced studies or in the data science industry. His insights today will help us understand not just the technology, but also how to stay current and apply cutting edge research in our future careers. So please join me in welcoming Mr. Abhineet Gupta. Over to you, sir.
Thank you so much for that introduction, Sanchit. It's great to be back here for the IIT Guwahati's course, Summer Analytics 25 course. If you didn't attend my previous MLOps talk, I recommend you to check that out. Hopefully, it's on YouTube. But today we are going to jump into LLMs. And before we start, we are going to run an experiment. So while we are doing that, whoever's joining, tell me where you're from in the chat, YouTube chat. And if you have some burning questions about LLMs, just mention those in the chat as well. What is some things that you are afraid of? What are some things you're excited about? And what are some things that you really don't know what it means when it comes to LLMs? And with that, let's jump into the experiment. So I am using here Claude Desktop. This is just an application by Anthropic, and I'm using their Claude models. So this is Claude Sonnet 4 that I'm using here, and I'm going to ask it a question. I am giving a 45 minutes talk on LLMs to a group of students, and let's say college students and young professionals. What else do we want to tell it? Who are taking a course on machine learning? Give me an outline for the talk. All right. So it's generating its answer, and we are going to come back to this experiment later. And yeah, so I'll jump into my presentation part of things. And yeah, please use the chat feature on YouTube, talk about where you're from and what do you want to learn about when it comes to LLMs. So, why is everyone talking about LLMs? What are LLMs? These large language models, or LLMs, they represent a very fundamental shift in how we interact with computers. Um, they have a much better understanding of language than ever before, and that allows us to ask things in a way that we just couldn't before. the experiment I'm running in the background with Claude, I asked a very sort of broad question, and we'll later see what it came up with. So that's why it's that fundamental shift. And we can use it to solve everyday tasks like I'm doing right now in that experiment, or very complicated tasks like coding up websites. And because of that, it unlocks immense productivity gains. I don't have to start from scratch when I'm coming up with an outline for today's presentation. And if I'm not a lawyer or a doctor or a marketer, I can ask simple questions to an LLM and gain some basic baseline for all these other professions as well. And I think what that does is enable us as humans to do a lot more tasks and to play a lot more different roles. And that is what's really exciting about LLMs. I have divided today's talk in three broad sections. I'll first spend time on the evolution of LLMs and kind of how LLMs came about to be, why they are different from natural language processing, and sort of what are some major shifts that have happened in the last 5 to 6 years that led us to LLMs. My next part will be how do we use LLMs to be better than what they are out of the box. So we'll work with agents. There'll be a live demo for that. And finally, we'll talk about the frontiers of LLMs, kind of where LLMs are going next. And that will be sort of the smallest topic that I'll touch on towards the end. All right, looks like people are not really using the chat. I really encourage everyone to use the chat feature, talk about where you're from, where you're joining from, and what are some questions on LLMs. And I'll be sure to kind of talk about those things during my chat, but also towards the end, I can try to answer as many questions as possible. So I'll jump into the first section. All right, some chat comments coming in. Air, Samriddhi, hi. And yeah, if you have burning questions about LLMs, add those in the chat. So let's talk about natural language processing, because as students taking a course in LLMs, you or in machine learning, you've probably heard about natural language processing, and natural language processing has been around for a long time. And why don't we use NLP anymore? Why are we calling these models LLMs? We'll jump into that. So if you look at the arena of natural language processing, pre-2010s or so, that is kind of when I was in school, we were looking at, started with rule-based systems, grammar was hard-coded, so a lot of kind of code that had to go into natural language processing for it to work, even kind of at a basic level. And this has been going on since the 60s, so a long period of decades where a lot of research is going in and more rules are being hard coded. And that wasn't scalable. Like no one really talked about NLP in early 2000s besides research. In 2000s, we started seeing some traditional ML models like SVM or naive Bayes for spam classification. So that really started touching on how we could leverage machine learning to improve natural language processing and natural language understanding. And finally, we started looking at embeddings. And embeddings are representing words which are fuzzy into a numerical representation. So that is typically a vector that we use, and the simplest embeddings are dictionary indices. So where a word is in a dictionary, if we have 10,000 words, each word can have an index in that dictionary, and we just represent the embedding with that index. So you can think of it as one hot encoding if you have read about that in your machine learning course. As we get into 2010s, so this is me now following up on the research and what's been going on, we are starting to see a lot larger data sets being used to train machine learning models. And that is improving the model's ability to process language. Neural network models are starting to get used more and more. There's new architectures that are coming in the arena, and those are improving the models that are being developed. There's improved embeddings like Word2Vec. If you haven't used Word2Vec, that's still kind of a very big standard library that is used to generate embeddings. And how it is different from dictionary embeddings is one, it tokenizes the words, so it will break the words into smaller parts. But two, it also uh, generates embeddings in a way that similar words have similar embeddings. And that's a really crucial property because if we talk about something like a pet and a dog, we want those words to have some similar meaning because the model needs to know that those words are similar. And if we use them in some language context, by having that similarity, the model can be trained better and then it can make inferences better. And as neural network models are being developed more and more, we are starting to look at next word generation using sequential models. And everyone's probably heard about Siri or Google Assistant. Those come out in 2010s. And then a transformational, and it's just don't mind the pun, but sort of a revolutionary paper that comes out talks about this architectural unit called transformers. And that came out in 2017. And that really changed what the world of natural language processing looked like and really laid the foundation for where we are today, where we have these very foundational models, which are we call large language models. And we'll talk about why we call them foundational models in a little bit as well. All right. So, people joining from Hyderabad, Panipat, Jaipur, Chandigarh. Yay! I'm from Chandigarh. Really excited to see you guys. And yeah, I see some questions coming in. If the IT Guwahati team can help me with some questions, just list them out, and I'll try to answer them as I'm going along in my presentation. All right. Let's jump into the next part. So I'm going to talk about briefly how LLM models kind of look like. It's, you know, with 45 minutes, I don't have a lot of time to really dive deep into the complexities of the model. So I'll keep it fairly high level. So hopefully we have a broad audience and everyone can understand what, at least at a high level, what is that evolution of LLMs from neural networks. So if you haven't yet talked about neural networks or are still confused about what neural networks is, at a high level, we have some input layer where, let's say, it is an image. Then there are a bunch of hidden layers, and how these hidden layers are constructed can be different. For example, for images, we used convolutional neural networks and then join different layers. There can be drop-off layers and so on. And then finally, there's an output layer. So in this case, maybe we are doing image classification. So we want to know whether that image is of a dog or a cat or a horse, etc. These layers are connected with weights, and during model training, we are learning these weights. And that is what constructs a neural network model. Those learned weights allows the model to then see a new image and make a prediction about what that image is of, what is the class for that image. During training, I'll quickly mention the way it goes is we initialize these weights, we go through these weights, get the output. If the output of the model does not match the real output because we are training, so we know the label, then we calculate a gradient and that gradient back propagates and updates all the weights. And we keep doing that with every image in our training data until we are satisfied with the performance of the model based on the weights that it has learned. But how I want you to think about the neural network is abstract out how all these hidden layers are constructed and think of them as a single model unit. And why I want you to do that is because it helps us to understand how the evolution happens from building these single hidden layers, individual hidden layers, to building a lot more complex models like we see today. And model units can be imported directly in like PyTorch or TensorFlow. So it also helps to just abstract out, not think about how different model units are constructed, but just say that there is a model unit that is available just as an import in PyTorch, and I'm going to use that. And there are some weights within that model unit that the model is going to learn. So if we look at a sequential neural network model, like we were using earlier in NLP, let's say each model unit here is an LSTM unit. So it has some concept of memory, and we are doing a translation task. So I have these inputs. I have this input sentence, "Hi, how are you?" And I want to translate it to "Namaste, aap kaise hain?" And I'll give this training data to the model. I don't care what this model unit is. I can replace it with RNN, LSTM, whatever I want. I can combine these model units together. They can be as many model units as I want. So it's really kind of chaining these model units, and then I'll provide a beginning token. And then if I'm training, I know the answer, and I'll train the model. And in sequential models, the previous token output, so this is the output of the previous token, goes as an input to the next token, and that's why these are called sequential models, and they are predicting the next word. So in this case, when hi comes in, namaste is the output, which is the next word, and so on. So these were early sequential models, but if you have used something like Siri or Google Assistant, they weren't really working very well. Um, they could do basic things, but half the time they wouldn't understand what you were saying, which is an audio challenge. But also, if they understood what you were saying, the predictions they were making weren't great. If you have used translations or summarizations, they're okay, but not great. And so NLP was kind of exists. We were all talking about that it's going to slowly improve or initially rapidly improve, but we just saw that it was improving very slowly. And so something changed. And that change started in 2017 with the transformer architecture. So I mentioned the transformer architecture was published in 2017 in this really seminal paper that I don't know if you've heard about it, but when you start learning about LLMs, everyone mentions attention or attention is all you need. And there are kind of people writing blogs about X is all you need. Where X is kind of people fill in with different things. But that's where it comes from. Vaswani and co-authors wrote this paper with this title, Attention is All You Need. And that became the basis of transformer architecture and really changed how we built models, especially natural language models. And I'll talk about where we go from natural language models with transformer units to large language models. So I mentioned it introduced this new architectural unit, the transformer. And why I was keep talking about model units is transformer is again a model unit, very similar to something like an LSTM or an RNN. And there's a lot of complexity that goes into it, but we can abstract out that complexity from the model unit, not think about exactly how it's functioning. In PyTorch, you can again import transformer just as an import function. But what we can do is combine these transformer units together to build our models. So the reason why this paper was called Attention is All You Need is this transformer unit is capable of paying attention to different words in a sentence. LSTM could do it to some extent, but it was very, very rudimentary. A transformer is a much larger model, so it has a lot more weights, and it does a lot better job at paying attention. So let's look at an example. I have this sentence after my presentation, Abhineet's presentation on LLM. Kabir asked him questions about how to use it for his hackathon project. If you look at this sentence, sort of looks like a fairly basic English sentence, but there are some fuzzy words here. So if we just look at some pronouns, him, it, his, are some words where these can refer to different parts of the sentence. And an LLM or a model may not know what parts each word refer to. And that is the situation we were in with NLP. But with Transformer, it knows that him can either refer to Kabir or Abhineet in this sentence, and it will correctly figure out that him refers to Abhineet. Similarly, the next word, it, can refer to presentation or LLMs. And in this case, both can be valid, but likely LLMs is a little more appropriate reference for it than presentation. And it will know that. So in terms of attention, it's not that it is only paying attention to one word at a time. It has an attention for all the words in this sentence, but it will just give more attention to the word LLM than it would give to the word presentation, and then all the other words it would give very low or no minimal attention to. So that's what, in essence, a transformer unit is. It's a model unit. Let's abstract it out, not talk about how it's constructed, but what it is doing is allowing the model to understand the sentences a lot better than what we could do previously. And it's a lot faster. It can be parallelizable. So those are some things that really helped us to train these models. So that was the first revolution in language understanding, this 2017 paper. The next revolution is the large part of large language models. So GPUs are starting to become available, and GPUs are a lot better at model training than CPUs. Initially, they were used for graphics, obviously graphic processing units, but what they were optimized for is matrix computations. And if you have built sort of any machine learning, large machine learning model, you know there's a lot of matrices involved. And that is also the case for neural networks. That is the case for transformers. And the matrix computations are a lot faster using GPUs than with CPUs. So there's a lot more GPUs, wide availability of GPUs, the costs are coming down, and larger memory GPUs are coming on the market, like 64 GB memory, even larger memories. So that helped a lot more companies, a lot more research institutes to train larger and larger models. The other thing that happens is people are experimenting with larger training sets. So if you think about a simple text document, just extract the text out, no formatting or anything. Typically, some kilobytes worth of document, even if it's like 10 pages, it wouldn't go above like 1 MB or something. So documents tend to be really small, but the training sets that we are starting to see is like 40 gigabytes to 200 gigabytes of text documents. So you can just imagine like billions and billions of documents that are being used to do model training. And if you look at more recent models, you probably hear about this term that they are trained on the entire internet. Uh, you know, entire internet here being you look basically scrape all the websites and grab text from them and then use that for your training data. So we have GPUs, larger training sets, and then the final piece of this puzzle is extremely large models. So we have these models with 100 million parameters initially, and these days 1 trillion parameters. So just if you think about the scale of the models that we're training, it's extremely huge. And these models are using the transformer units that I just described. So you just kind of combine all these transformer units together, add more transformer units, and so on. And within the transformer unit, you have this concept of multi-headed attention. So instead of having just one attention unit where you know that what is how to pay attention from one word to the rest of the sentence, you actually create multiple heads where the model learns how to pay attention to different parts of the sentence simultaneously. And this improves how the transformer unit learns about the language. So a lot of text here, but just kind of think about this as the first revolution is transformers, and the second is larger models and larger training sets. And the final thing that changes this landscape is emergent ability. So if you have been training models in your machine learning course, this is probably a typical curve that you have seen, where if you're increasing the model parameters and you're looking at your test error or test loss function loss function on your test set, then with more and more parameters in your model, the test error like would decrease first because the model is learning something more with more parameters. But then after some point, the model will start overfitting and the test error will start increasing. This is kind of where everyone was even just 10 years ago, how our understanding of machine learning was. And what people would do is plot this test error and say wherever this bottom is kind of the best model set of model parameters to use for a given data set. But im- um what was observed when people started training with larger training sets is as they were kept increasing the number of parameters, the test errors started decreasing again. So it would reach this peak and then start improving. And this phenomena came to be known as double descent. And this really changed how we think about machine learning models and larger machine learning models. So the models, when they grow really large and are trained on large training sets, add these abilities, and these abilities are called emergent abilities. We don't completely understand what these emergent abilities are, but the model performance of these large models is a lot better than if we had smaller models kind of in this range. So as the number of parameters in the training sets are growing, this is the bet essentially that OpenAI took, that we are going to just throw models at it. And that's why, if you have heard the news, they say it takes hundreds of millions of dollars to train a model because they really started experimenting with more and more parameters into the model and finally reached this double descent arena where their models started performing a lot better than previous models. And so, if we look at LLMs and compare them to traditional natural language models, they're a lot larger and they can do a lot more things. They have a lot better understanding than previous natural language processing models. And what we are seeing today with LLMs is one, they're generative. What that means is previous NLP models tended to be discriminative. So if we were doing spam classification, we are trying to discriminate between a spam email and a non-spam email. Or we may have a task like product recommendations or sentiment analysis, and those tend to be discriminative tasks. Versus LLMs are generative models. All LLMs today kind of focus on this idea of generating the next word. And it expands the number of things that we can do with LLMs. I can ask a broad question to an LLM, and it can give me an answer in words, kind of that addresses my question. And that takes us to the next part, that these are foundational models. Why we call them foundational models is because the same LLM can now accomplish multiple tasks. So again, previously with NLP, if we wanted to do spam classification or sentiment analysis or summarization, we had different models for each of those tasks. Each model would take weeks or months of training, and then we would look at their performance. We would optimize hyperparameters. Like there would be a lot of work needed to build a model to do one task. But with LLMs, we don't need different models. If we want to do sentiment analysis, I can just ask the model, hey, this is a comment that a user wrote on my product, and are they happy about the product? Are they mad about the product? Are they angry? Are they sad about the product? They're satisfied, not satisfied. I can just ask the LLM those questions and it will answer me for me. Same if I want to check if an email is spam or not, I can throw the email in there and ask it whether this looks spammy or not, and it will answer those questions for me. So I no longer need to train um, new models for each task. So that's why these are called foundational models. And then the final thing that these models allow us to do is advanced reasoning. So not only can they are they just predicting the next word, but they have this sort of some level of inherent reasoning capability that they can solve problems that they may never have seen before. So even though they have large training data and m- maybe the idea of LLMs that you have is they are just throwing the next word based on what they have learned. In fact, I would challenge that and say that they are doing some level of reasoning. How they're doing it, we don't know yet. That's an active research area, but they are doing these reasoning, some level of reasoning. And this allows us to really kind of solve more complex problems like coding challenges and law exams, which we probably heard in the news again. So we are going to run another experiment. And for this experiment, I am going to ask it a question where hopefully it will have to reason, and we'll see how it responds with that. So don't pay attention to what's on the wall right now. We'll come back to that, but we will ask it a question, and I want audience participation again for this question. So what I am going to start with is say, your task is to build the tallest structure from a list of objects that I give you. The objects should be fairly balanced, and you should give me the reason for why you think your suggestion would lead to the tallest structure. So if you so as I'm typing this out, think about some objects that I can give this problem. Hopefully, with the audience participation, it would be a list of objects that the model has never seen, and we'll see how well it reasons through this problem and comes up with the tallest structure. So I'll write some objects just to start us off, but then I really want the audience to come in and just whatever comes to your mind, throw some objects which can be stacked together, and let's see what the LLM does. From a list by stacking a list of objects that I give you, the object should be fairly balanced, and you should give me the reasons for why you think your suggestion would lead to the tallest structure. You can stack the objects in any order. And here is the list of objects. So the first thing I'm going to do is say you have 3 cartons of a dozen eggs. Okay, so I got some eggs in there. Let's see what else. Okay, you have 12 bottles of Coke. Okay, so let's see. Audience, what suggestions have you been coming up with? Uh, uh, um, all right, I think we are still waiting. Think about some ideas, some things that you want to put in this problem, and we'll ask the LLM to come up with the tallest structure. So I'm going to wait for people to enter their some ideas in chat, and I'm going to provide those to the LLM. Burj Khalifa. I think Burj Khalifa is already tall. 50 boxes of pencils. I love that. Love that idea. Let's do that. 50 boxes of pencils. Let's see what else is coming. 10 notebooks. Perfect. 10 notebooks. 10 notebooks. All right, let's take 2 or 3 more suggestions from the audience. Think about something that maybe is not very easily balanceable. Um, let's say uh, 12 forks, 10 bottles of water, 10 notebooks. I think bottles of water, thanks for the suggestion. I have bottles of Coke, so I'll kind of let's change that to bottles of water. Um, okay, I'll take a couple more suggestions from the audience. Let's make it 7 objects. So keep your ideas coming in. 1 carton of mangoes. I love mangoes. I miss mangoes here. We don't get good mangoes in the US. I was in India earlier in May, and I had so many mangoes. They're so delicious. All right, one last suggestion. 50 boxes of pencils. I think I have that already. Ishita, milk cartons. That's great. I remember Amul had these kind of plastic bags of milk. So let's see. Let's make that more interesting. So I'll say, um, let's say six plastic bags of um, 500 milliliter milk. Okay, let's see what the LLM comes up with. All right. So far, so good. It's saying that it needs to consider height maximization and structure stability. My recommended stacking order, bottom to top. All right. So at the bottom, 50 boxes of pencils. Okay, so it's giving us a grid pattern as well. Because it's 50, it's saying 5 by 10 or 7 by 7 plus 1. Pencil boxes are typically small, rectangular, uniform, and will create a wide stable base. Then 12 bottles of water in a 3 by 4 grid, standing upright. All right, so it also knows that it cannot lay down, it has to stand up. They are heavy, cylindrical, and that will provide stability. 3 cartons of eggs arranged in a triangular pattern. That's interesting. So because that was 3 cartons, instead of creating a grid, it created a triangle. 10 notebooks, and they are flat, relatively stable. And then 1 carton of mangoes centered on the notebook stacks. So maybe what it did was it said, because I have created this triangle with my carton of eggs, I need to now sort of make it more uniform. So it's adding those notebooks on top of the carton of eggs and then putting the carton of mangoes on top. Sixth layer is the milk bags arranged in a 2 by 3 pattern laid flat. They're flexible, will conform to the surface below, but will still create a platform despite their irregular shapes. And finally, 12 forks bundled together, standing vertically. Um, all right. So it has a white stable base, blah, blah, blah. All right. So I think that's a fairly good answer. I don't know if you have any ideas for how you would change this structure to be taller. Maybe I would have put the notebooks stacked vertically. I think it's stacked them flat, and I could get a bigger, taller structure. I have 10 notebooks, which are a lot, that I can stack them vertically. But this kind of gives you an idea of why I'm saying that LLMs have these advanced reasoning capabilities. I got these suggestions from you. The model hopefully has never seen this list before, but it could kind of reason through how best to stack these objects to make them stable. So really, I think honestly, personally, I think it's really cool stuff that LLMs can do this, and that's what makes them so powerful. All right. So with that, I think we have talked about how LLMs came about, how they're different from traditional NLPs, and it's time to kind of jump into the next topic, which is how do we now take LLMs and make them better for the tasks that we are going to do? So this is about kind of supercharging LLMs with agents, and I'll talk about that a little bit. The first thing, though, before I jump into agents, is prompt engineering. Again, this is a term that you have likely heard about. Prompt engineering is we write different kinds of prompts in an LLM, and based on that, we hope that the LLM answers better things, right? So in the example that I just worked on with the reasoning, I tried to be very specific about what I wanted the LLM to do. And the more specific I am, typically the better the LLM performs. Similarly, I didn't give it too many tasks. I gave it one task, and LLMs work a lot better at doing one task versus multiple tasks in the same prompt. So people have been experimenting with different kinds of prompts and coming up with sort of what are the prompts that work the best. Some examples are kind of few shot prompts where we can take sort of some examples of what we want the LLM to do. For example, if we are doing sentiment analysis, I may give it 3 or 4 comments and say each comment, is refers to the customer being happy, this refers to the customer being sad, and based on these examples, now I'll give it a new comment and ask it, what do you think the sentiment of the customer is? Similarly, if I want formatted outputs, I may tell it how to format an output, what is a valid JSON, for example, so it can answer in with those. The next thing, that how LLMs are being sort of supercharged, how LLMs are being used beyond their basic capabilities, is what is called RAG, or retrieval augmented generation, where people are attaching resources to an existing LLM. So an LLM like Claude, which comes out of the box, maybe doesn't know about a new repo that you just published, or a new product that a company just launched. And what we can do is attach the documentation of that product to an LLM, just provided those documents. Similarly, if you're building a chatbot, maybe there's some company policy that people had to follow before, who you were chatting with, or who you were raising complaints with. But now all those policy docs can be attached to an LLM, and the LLM can just go through those documents and answer based on what it sees in the documents, instead of only based on what it has been trained on. And finally, there are agents. And agents are tools that we attach to the LLMs for it to use. For example, we can attach a tool like a Python compiler, and an LLM can, in fact, write Python code on its own and then run the code to know, one, whether it works or not, and two, whether it's doing the thing that we have asked it to do. And agents, I think, are the most powerful way in which we are expanding the capabilities of LLMs today by attaching all these new tools to LLMs. And how agents are being used, this is something very recent. It's called Model Context Protocol, MCP. It was published just about 2 or 3 months ago. It's all the buzz in the LLM arena right now. Everyone's talking about MCP, so it's fresh off the press. And what it does is it provides a unified way to attach prompts, resources, and tools to different LLMs. So we don't have to worry about which LLM a customer is using or a user is using. We can build we can just focus on building tools, and those tools can be attached to whatever LLM or user decides to use. So what, as developers, we do when it comes to MCP is we create MCP servers that then users use through a client interface. And I am going to do a live demo, and we'll see how well it works, or maybe it won't work. And that's how it goes with live demos. But we are going to do that and build our own MCP server right now. And I have a small repo where I have an MCP tutorial. So after this presentation, if you want to kind of get your hands dirty and follow along and build your own MCP servers, you can follow that on the repo. But I am going to open my Claude editor, or sorry, VS Codium code editor, and I'm going to create a new MCP server. So the calculator is what is already in the tutorial, but I am not going to create a calculator. I am going to create a new server. And what I'm going to do is create a server for trigonometry. All right. And also, I am not going to type everything myself. I am, in fact, going to ask my code assistant to do it for me. So let's see. I have this code assistant. I create a new chat and I say, create an MCP server with fast MCP decorators to add tools for the following basic trigonometry functions. No, did not mean to press enter. Let's do that again. All right, so I want to convert degrees to radian, convert radians to degrees, take sine, cos, calculate, not take, calculate, sine, cosine. So while I'm typing this in the chat, if you have any questions, add them. The team at IT Guwahati will hopefully help me sift through those questions, and I'll try to answer those questions at the end. So ask your questions, whatever I've talked about, or whatever questions you have broadly about LLMs, and we'll address them. So calculate sine, cosine, and tangent um, of an input in radians. All right. So um, this is honestly, I use Code as uh, a code assistant every day, and it really makes coding so much easier. I don't have to worry about syntax. I don't have to sort of type out everything. It can give me basic sort of setup of a of whatever I'm working on, and then I can just go ahead and improve upon it instead of starting from scratch. And towards the beginning, I mentioned this LLMs have this capability of increasing our productivity, and this is an example of how it does that. So let's quickly look at how well the LLM, this code assistant I'm using, C-line here, um, wrote created this MCP server for me. All right, so it did degrees to radians, radians to degrees. It calculates sine, cosine, and tangent. Perfect. So I think it has some tools that I've added. So each of these are tools in the MCP context. And then, as I mentioned, so as developers, we create these MCP servers. So I've created this MCP server. I need to be able to run this server. So I use this environment manager called DevBox. You don't have to worry about it for now. I am just going to write a new command to run this server. So we just created this. So I will say trigonometry, and it has to run trigonometry.py. All right, so that's all it's doing. I'm just setting up a new command. And then I am using Claude Desktop today, which is going to be my client, which is going to interact with this MCP server. And Claude client has this config file where you can add your own MCP server. So I just created this uh, new server trigonometry, and I am going to add this. So call this trigonometry, and it's has the right location, run, and I gave the command trigonometry. All right, so that's it. And I will go back to my Claude here. I think I have to restart it. So I will restart it. Before I do that, be remember I had this question. I'm just going to copy it so I can show you the output later. So this was the question I asked, and the answer Claude gave me was All right. So just give me a moment while I restart my Claude desktop. All right. And we will see if, all right, so MCP did not work. Maybe trigonometry worked. Let's see. All right, so I do have the trigonometry here. For some reason, the calculator stopped working. I can debug that later, but I am going to test this out. So how can I help you today? Calculate the sine of 90 degrees. All right, it's telling me it can use the trigonometry tool. So it figured that out on its own, that it has access to these tools. And this trigonometry server has this function of converting degrees to radians. Because remember, it can only calculate the sine, cosine, and tangent of an angle in radians, but I gave it an angle in degrees. So it's sending that request to my server, and it says, okay, now it needs to use the sine tool. And let's see, the sine of 90 degrees is 1. Perfect, right? So you can see here, we built an MCP server live, and it did all these two different things, and it knew how to do them. So this is kind of the power of MCP, that you can uh, create these servers, just add new tools to them. You don't even have to worry so much about how MCP servers are created. Just ask your code assistant to set it up for you and provide them to your client, and you can use these amazing tools. So again, if you have some repo you want your LLM to access, or you want to run a code compiler, you can easily create these servers, provide those tools, and the LLM will figure it out on its own how to parse the question that you have into a format that the tool can use, send that information to the tool, run the tool, and get you the answer, and provide the answer again in natural language. So um, I think it's really cool that we can do this. I'm really glad this live demo worked. It's always a toss up. And hopefully, through this live demo, you kind of are thinking about your own tools that you can build so you can play around with them. All right, with that, let's jump into the last section as we are coming up on time as well. So we'll talk about where LLMs are going next. And what are some active research areas in LLMs? So the first thing is truthfulness. You've probably heard about the word hallucinations. Hallucinations is just kind of a nice way of saying LLMs lie. Um, and a lot of times they do. They can make up stuff. In this case, I was very specific about the prompts I gave it. But if I just told my code editor, write some trigonometry functions, I don't know what it could have come up with. So I was very specific about that. It just calculates sine, cosine, and tangent. But hallucinations is a big problem, especially if you're asking facts. If you are ask it a broad question like what is an LLM, or what is a transformer, you don't really know whether it's going to give you the correct answer or not. And that is currently a big problem with LLMs. And some ways in which this is reduced is there are guardrails that are built. Basically, you tell the LLM, you provide a system prompt to say, do not lie, do not hallucinate, only use the information that I give you, etc. And hopefully the LLM will be a little more truthful or a little more fact-based, but it doesn't guarantee anything. Because ultimately, even though there are reasoning capabilities in LLMs, they are still predicting the next word, and sometimes the information that they were trained on is just wrong. Another way is reinforcement learning through human feedback, which is RLHF. Again, improves some truthfulness, improves trustworthiness of LLM models. The second active research area is multimodal LLMs, and maybe they won't be called LLMs, they would just be called large multimodal models, LMMs. I don't know. We'll see. But it's basically going beyond text inputs to other forms of media. You know, in the real world, we don't just work with text, we work with images, videos, audios, and already a lot of models can use those as inputs. But then there's also a big opportunity in generating audio, generating images. And there are tools for that, but they are pretty rudimentary right now. So an active research area for taking LLMs and making them multimodal. And once we can sort of gain those abilities, the final thing is this concept of artificial general intelligence. So I talked about LLMs are foundational because they can do so many different things out of the box, but they are still not able to do everything a human can do. And there's a long way to go. But before LLMs, I think it was not even possible to imagine that models or computers could match the intelligence of humans. But with the advent of LLMs, I think it has started to look like it could be a possibility. And there's active research going into artificial general intelligence where models can basically do any task that a human can do. And with that, I'll take you to my last slide, which is how do you begin your LLM journeys, or after this talk, what can you do to be sort of better stewards or better students of LLMs? So even 10 years ago, what computers could do, what models could do was very limited, right? Like I love this comic because um, this is from about 10 years ago. It talks about if you take a photo, check whether that photo was taken in a national park. Really easy with a GIS lookup. But if I had asked, check whether that photo was of a bird, you would have needed a research team. But today you can just throw that photo in an LLM and it will figure it out for you. There's no coding required, no research required. So we have made a lot of progress with LLMs. And as you think about your LLM journeys, I think you are in this very unique position that you are starting and seeing the growth of LLMs from the beginning. Imagine kind of 50 years ago, 60 years ago, when computers really started to come on the market and people, you know, some people's early software engineers, software developers could see how computers evolved and they had this very strong sort of presence in the computers domain. Like we call them fathers, mothers of computers or software. I think you could be one of those, fathers, mothers of LLMs. You are in this unique position. You're seeing their growth all the way from the beginning, and you can evolve it, but you can also sort of lead the charge on what LLMs of the future or what AI of the future could look like. And as students, I think you have so much energy. I just invest that and go explore LLMs, work in LLMs, work in AI. And with that, kind of use AI today. There are tools, a lot of them are free. Some you have to pay, but they're really, really cheap. Kind of when you start using them. For example, let's quickly look at this thing that I just asked the LLM to do. It cost me 6 cents to run this query. And what it did for running this query is look at my entire repo, understand what other code I had, and based on that, based on my prompt, it gave me the answer. So it can be really cheap to use, but even if you don't want to pay money, use like ChatGPT, Claude Desktop, and you can do a lot of things for free. So use AI, get familiar with AI. Keep learning about LLMs. I hopefully gave you a broad idea of what LLMs are, where they came from, how they are developed. But LLMs are evolving so rapidly. Like MCP that I talked about today, it, it's not even 3 months old. Like I don't fully understand what MCPs are, but with LLMs, I can use them and create my own tools. So try to sort of keep learning about LLMs, and it can be overwhelming. If you can't learn about everything or can't follow everything, it's okay. whatever you can, whatever opportunities you can, just take that opportunity and learn about what's going on in the LLM world. And this point is really important. Get your hands dirty. The best thing you can do to learn is to build your own applications, build your own things. If you have a tool in mind that you were like, I wish the LLM could do this, I showed you, like, took me 5 minutes to create a new set of tools. Just create your own tools. Like, maybe you'll create the next sort of Google or next big application, or maybe just you'll do things a lot faster than your colleagues and your friends. So get your hands dirty. I had the link for the MCP tutorial on my repo. Start with that and try out how you use LLMs to build your own applications. And the final thing, always validate your results. I think, and someone else has said it, that LLMs, we talk about sometimes they're hallucinating, but honestly, they are hallucinating all the time. And just sometimes those hallucinations are correct. So never trust an LLM. They can be wrong a lot of times, and always validate the results that you're getting from an LLM. So hopefully this motivates you. This like the presentation I gave today sort of encourages you to get your hands dirty. If you are afraid of LLMs, hopefully you're not afraid of them anymore. Um, and I can't emphasize this enough. Use AI. Personally, I think AI is going to be like the computer revolution. It's going to be everywhere. And the sooner you can sort of understand it, the more proficient you will be, and so the more successful you will be in your careers. And you don't have to be a computer scientist. This is going to be everywhere. So even if you're a doctor, you can use AI to help you. Even if you're a lawyer, you can use AI to help you. Like, whatever profession you are in, just play with it. It won't always work. You'll get frustrated, but you'll learn. LLMs are going to get better, and you will be the person who can leverage AI and LLMs to be the best version of the profession that you are in. All right, with that, before we jump into Q&A, we have one final thing, which is look at the answers from the experiment that we ran at the beginning of the um, presentation. So I asked it the question. Let me make this bigger. I asked it a question that I'm giving a 45 minutes talk on LLMs to a group of students and young professionals, and you have to give me an outline for the talk. This is the outline that it gave me. Understand the technology behind ChatGPT and beyond. Uh, Poll. It suggested me a poll. Who has used ChatGPT? I did not have that poll. Maybe I should have. That's a very good suggestion. What are large language models? So we talked about that today. We talked about neural networks, transformer architecture, why large makes a difference. Oh, it also mentions emergent abilities. We talked about that, how LLMs work under the hood. I think we didn't go too deep into it, but we kind of briefly touched on transformer architecture, large text corpora. We did not talk about semi-supervised learning or fine-tuning. Let's move on. Capabilities and limitations. So we talked about hallucination, we talked about reasoning, text generation, um, applications and impact. So maybe we didn't go too deep into it, but we did a live MCP demo, which I think is great. So I think it gave a good outline. I don't know. Tell me in the chat whether you would have liked to see more from this outline, or you like my talk better. But yeah, see, like, why I ran this experiment is LLMs can do a lot of things for us. Like, I can, when I'm trying to give a new talk, I can just ask an LLM where it would start and use that as a basis for what I would like to do. My talk wasn't exactly the same, but we touched on a lot of similar things, similar ideas. And then based on sort of what I thought would be best for the audience, I kind of designed the talk based on that. And I think I ended up doing quite well. So kudos to me. Anyway, tell me how you liked this talk, whether you thought it's better or worse than the outline that LLMs gave. And with that, we will jump into Q&A, the best part, because I love interacting with the audience.
So I've created a list from the chat. So can I just present it to you?
Yeah, please. You can
Right.
ask
So
me questions from the chat, and I can just answer those.
right. So before that, great insights on the MCP and I think the live demo and also the Claude prompt. I think it's going to help the participants a lot. So the first question, I think I will go from LLM based questions to career based questions. So Samriddhi asks, how do you evaluate an LLM's performance?
That's a great question, Samriddhi. How do we evaluate an LLM's performance? So, right now, what I was doing was this kind of manual work where I would ask an LLM something, it would give me an answer, and as a human, I can evaluate the work. But when we start building scalable applications, where maybe I'm building a chatbot for a company, then I don't know what are the different prompts that a user is going to ask and whether an LLM is going to give a correct answer or not. And one of the main strategies that are used today is what is called LLM as judge, where we act because the scale is so large and we cannot just kind of even to understand the answer and whether that answer is correct or not, we need an LLM to understand it. Um, we end up using LLMs as judges. So an example here can be like I asked a simple question to an LLM. I ask it, what is 10 plus 20? And it gives me an answer. The answer to 10 plus 20 is 30. It is a correct answer, but I cannot just provide that answer to something like, yeah, I don't know whether that answer is correct or not because it's a sentence, right? And so what I will do in this case is, let's say I used one model, Claude, for generating this answer. Then I will use another model like GPT-4 and say, hey, evaluate whether this is the correct answer to this model. And if it is, then that gets marked as a correct answer. And that is how now I can quantify the performance of an LLM. And we can do kind of a lot of interesting things with it. So the way it's typically done today is simpler models are used to generate the answers because we want the costs of our application to be low. We don't want the best model to always be live because we have to then pay for every query we are running to OpenAI or Anthropic. So we'll use simpler models like Claude Sonnet 4 or GPT-4 to answer users' queries. But then we will use more advanced models like there is a Sonnet Max that Anthropic released recently, or GPT has this O1 model. So we'll use more advanced model to use as judges. So that's how typically LLM evaluations are done by using another LLM to evaluate the results.
Right. So the next question, with the advancements of the LLMs, how does this affect the careers in the industry, and what changes do you see?
That's a broad question, so I will kind of fall back to what I mentioned in my last slide that AI is coming to every profession, and obviously it's a prediction. Like it's my personal opinion. The reality could be different, but I have been using AI. I've been using LLMs for almost 2 years now, and I've seen kind of the growth. I mentioned I use AI, I use code assistants in my daily work, both at work and my personal projects. And I find myself kind of being a lot faster at the things that I do, especially when it comes to coding. Just a few months ago, I uh, I know Spark, for example, but I needed to build that same application using Beam, and I just asked my code assistant to help me with that, and that sort of became the basis of translating the code I had in Spark to now using Beam for it. So the what I think we are seeing is by using AI, we are getting these productivity gains. We are sort of moving a lot faster with the things that we can do. And that is true not just for coding, but for other professions as well. Like if you if you are signing a contract tomorrow, let's say you are renting a new apartment and there's a lease for that, and you don't know whether there is something in that lease document that you should be worried about. So you just kind of attach that lease document to your LLM and ask it, hey, what are some key important things in this document? Are there some things that I should be worried about or talk to with my landlord? And it'll give those suggestions to you, right? So now you don't have to be a lawyer. You can just be, uh, you know, someone being studying medical science or someone, you know, you can be anyone, but you can have those basic legal capabilities. Similarly, if you're not feeling well, you can ask an LLM something and it will give you some answers, and it's a lot better than WebMD, which always tells you you have cancer, which hopefully you don't. Um, how it's affecting our careers, I think, as you are growing in your careers, if a company is hesitant to use AI, I think that company is not going to be successful in 10 years. So, focus on companies that are open at least to using AI, that are exploring AI tools, because if you're not using them, then you are a lot slower. You are spending a lot more money doing the same task that another person can do who uses AI. And I also mentioned it's not only about coding where it can help, it helps with everything. So whatever profession you are in, think of it as computers. Everyone uses computers in all professions today, and in 5 years, 10 years, everyone is going to be using AI in all professions. So just get your hands dirty. You don't have to be an expert. You don't have to be an AI developer to use AI. Just think of it as an intern or an army of interns that you have, and you can just ask those interns to do something for you. And sometimes those interns will give you the wrong answer, but sometimes, well, a lot of times, like if you combine an army, you will get to where you want to go.
That's interesting. So the next question is asking for your experience in academia as well as the industry in this ML field. What are the experiences and insights that you have to share with the participants?
Yeah, so my experience in academia now is like 10 years old, and LLMs wasn't even a thing 10 years ago. We were still, I think it, honestly, for me personally, until OpenAI started talking about GPT and really published GPT, I thought everyone was talking about images. Like CNN was the big thing. Everyone was just like image classification, image research, and suddenly LLMs come on the field, and everyone is now talking about LLMs. So I've seen that shift. When I took courses in machine learning, I was learning about support vector machines. No one uses them these days. Kind of decision trees was just briefly mentioned, and now if you are talking about traditional LM, traditional machine learning, decision tree is like the first thing that you would explore with on any problem that is given to you. And similarly, when where we are today, if people are starting to talk, if someone is asking, hey, I want to build a chatbot and I want to build use natural language processing for it and build my own model, sort of my default answer is, why would you spend time building your own model when these foundational LLMs already exist? And you don't always have to pay companies to do that. You can self-host LLMs. Like I have a personal project where I build self-host an LLM or self-host a clipboard model, which is a transformer-based model to do image search using natural language processing. And it doesn't cost me anything because I have a server and I have just set it up there, and I'm not sending any requests over the internet to do that. So just leverage what already exists, and these models can do a lot of different things. And improve kind of your productivity and make you a better developer, or again, whatever profession you're in, make you better at it. Yeah, so uh, academia, I think, also can tend to focus into depth. So if you are in academia and maybe learning about AI, Today I talked about transformer as a model unit and I said abstract out the complexity of it. But if you are in academia, you will likely not abstract out that complexity and really go deep into how a transformer is constructed. Similarly, in LLMs, I talked about embeddings very broadly, like word to vec is what I talked about, but there are now rotational embeddings that you can use. So in academia, you would go into the complexity of a lot of those things, but once you go into industry, or if you go choose to go into industry, a lot of those complexities are abstracted out, and mostly what you're doing is kind of either, if you're building your own models, you will just pull or import the transformer unit into your model, or you wouldn't even be building your own models. You will just be utilizing these models. And the goal, sort of in academia, the goal is research and depth and publishing papers. And the goal in industry is shipping products. So you need to be able to ship products really, really quickly. Yeah, so that's some contrast between academia and industry and sort of my journey.
Right, so so the last question for today, I think it's a very prevalent question. If you were to start out in the field of ML today, what is your next step? What would you do if you were to do it again?
Uh, now I feel like I'm being interviewed. So I have to really think about this if I were to do it again. Uh, I don't know if I would change it that much, but I think early ML models that I developed, I spent less time than I should have on model validation. And I think that is an important skill, but also something really important as an ML engineer that you should always keep in mind. I think Samriddhi, when she asked the question about LLM evaluation, that's a really relevant question because building models and training models is easy, but knowing how those models work for the users is tricky, right? Like if you have an imbalanced data set, don't use accuracy as your evaluation metric, right? Like even basic things like that. Like pay attention to them. How do you know that a model is working well is something that I think any sort of successful machine learning engineer needs to know and really have a depth of knowledge in. Um, as you are sort of growing in your careers or moving into industry, a lot of you will likely never be training your LLMs. But you will be building other models on top of LLMs. For example, the tools I showed you may be building those tools, or you may be writing interesting prompts, or you may be attaching resources. And you'll need to know how do I evaluate the model's performance. Even if you're not using LLMs, you're building your own machine learning model. Let's say you're building a random forest model. Depending on the problem that you have to know how do you validate this model. And validation is also sort of there are often in industry these two different groups of validations. There's one set of validations that you as an ML engineer would use just to understand your model's performance. Let's say you're doing hyperparameter tuning and you'll need to know what's the best evaluation metric to use. In classification of an imbalanced data set, let's say you choose to use precision or you choose to use F1 score for that. But then there will be this other set of metrics which will be relevant for the business use case. Your customer doesn't care about what the precision is. Your customer cares about sort of whether they will make money if they use this model or not make money if they use this model. So now you have to translate what your model's performance is into something that your customer cares about. And as an ML engineer, you have to think about both those sets of evaluation metrics. Otherwise, you can build the best model and your customers may never understand why it's the best model or use those models.
Right, so well answered. So with that,
Thank you.
on the
Did I
behalf of the
get the interview? Ace the interview?
yes, yes, you did.
Perfect. Thank you.
Anyways,
Thank you, Sanskrit.
so on the behalf of the Consulting and Analytics Club and all the participants today, I'd like to thank you for this engaging session. Your guidance on LLMs and sort of navigating through the research literature has helped us today. I'm sure all of the participants have found your skills invaluable. and with their next step, whether that's in the industry role or in their academic pursuits, it'll be really helpful. So, thank you again, Mr. Abhineet Gupta, for all your expertise and sharing your time. Another great session with you. Thanks.
It was a pleasure, Sanchit. Thank you, everyone in the chat who participated. I know I couldn't follow the chat today as much. There was a lot of content to cover, but with the live demos, hopefully it was an interesting chat. And yeah, it was my pleasure uh, hosting both these sessions on MLOps and LLMs. And I have my LinkedIn here. So if you have any questions, if you just want to say hi, reach out on LinkedIn. And yeah, have a great rest of your night, everyone. And it was just amazing presenting to this audience. You are just an amazing audience, with so much participation in the chat. I loved it. And
I
thank you
can,
to
I
the
can,
IIT Guwahati team for the opportunity.
I think I can convey a thank you from participants and the team. So, thank you again.
All right, bye.